several methods. We'll look at even numbers, whole numbers, odd numbers. We'll cover all of these things in this video. So it's going to be a long video, but I promise that every second is going to be a valuable information. You are going to be grateful that you stayed to watch. Now, here are the things you need for this lesson. You need a very sound environment. You need your book and your pen. And if you can get an earpiece, I'll be grateful, because I want you to hear everything that I'm going to say in this video. Now, let's get right into it. So, when we talk of factors of numbers, it means something very simple. It means the set of numbers that can all divide a particular number. So, for example, if I ask you what are the factors of 2, all right? I mean, what numbers on earth can divide 2 equally without a remainder? All right, we are looking at without remainders, okay, because there are billions of numbers that can divide 2, but we won't do that. When they divide 2, there is no remainder. An example of such a number is 1. So 1 can divide 2 how many times? 2 times. So 1 can divide. All right, and then what other number can divide 2? 2 itself. All right, so 2 can also divide what? 2. So in essence, this 1 and 2 are what we call the factors of this number 2, because they can divide it. What about 8? All right, so what numbers can also divide 8? 1, right? 1 can divide 8. 2 can also divide 8, because 2 times 2 divides 8. That how many times? 4 times. So 4 can also divide 8. 6 won't divide 8 without a remainder. There will be a remainder of 2, right? So it's not part of the factors. It's not what you're interested in. We are interested in those numbers that when they divide it, there is no remainder. Then 8 itself will divide. All right, so we are 1, 2, 4, 8 being factors of what? 8. Now I'll show you a trick I was using when I was in grade 6. What I do is this. So let's say you want me to get all the factors of 8. All right, so I'll write 8. So I write all the whole numbers of 8. So 1, 2, 3, 4, 5, 6, 7, 8. All right, then I'll be checking. So I'll pick 8 here. So 1 divides 8, so I'll circle it. 2 divides 8, how many times? 4 times, so I circle it. 3 divides 8, yes, but there's a remainder, so it's out. 4 divides 8, yes, but there's no remainder, so I'll circle it. 5 divides 8, yes, but there's a remainder. 6 divides 8, but there's a remainder. 7 divides 8, but there's a remainder, so it's not. So then 8 itself. So these are the factors of what? 8. Okay, what about 12? So this is for 8, so I write 8 here. What about 12? So 12, so I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and then 12. All right, so these are the set of whole numbers from 1 to 12. So I check. So 12. Can this 1 divide this 12? Yes, it will divide it. So I circle it. What about these 2? Yes, I circle it 6 times. 3, can it divide 12? Yes, 4 times. So I circle it. 4, can it divide this 12? Yes, 3 times. So I circle it. 5, can it divide? No. 6, yes, without a remainder. So I circle it. 7, no, there's a remainder. So 8, even though it can divide, but there will be a remainder. 9, remainder. 10, there will be a remainder. 11, there will be a remainder. 12, there is no remainder. There is no remainder, so I circle 12. So my factors of 12 are 1, 2, 3, 4, 5. Sorry. So the factors of 12 are 1, 2, 3, 4, 6, and 12. So 1, 2, 3, 4, 6, and what? 12. All right. Now I was enjoying this method so much. All right. I was using it for smaller numbers less than 20, and it was working so well. But the limitation to this method is, what if I'm supposed to find all the factors of 48? Am I going to write 1, 2, 3, 4, 5, 6, 7, 8, 9, all of them up to 48? I mean, look at the time I'm wasting in doing that, and also it's not going to be effective. All right, imagine you're supposed to find all the factors of 128 or even 500. Are you going to be listing right 1 2 3 up to now? This method though is okay, but it has a lot of complications. It's okay for numbers less than 20. So what do we do? Here is a problem. So what do we do? I'll show you what to do. So there are lots of methods being developed now to help you find factors of numbers, and one of them is this, that you use the division multiplication method. So let's say I supposed to find all the factors of 12. So we pick 1 times what gives you 12. 1 times 12 gives you what? 12. Then the next number we can think of is what? 2. So 2 times what gives you 12? 6. So you see we are moving on. So the next number 3 times what gives you 12? 3 times what? 4 gives you what? 12. So automatically we've exhausted all the numbers. So the factors of 12 now are 1 2 3 4 6 and what? 12. Let's then use this method to also find all the factors of 24. So we go 1 times what? 24 gives you what? 24. Okay, yeah. The next number you can think of, because 24 is even, try 2. Can 2 divide 24? Yes. How many times? 12 times. So 2 divides 24 12 times. The next number you can think of, 3. Can 3 divide 24? Yes. How many times? 8 times. Good. What about 4? So 4 times what number gives you what? 24. 4 times 6 is what? 24. The only number between 4 and 6 is what? 5, and 5 cannot divide 24. Therefore 5 is not included in the set of factors. So therefore the factors of 24 are 1 2 3 4 6 8 12 and what? 24. Good. Now this method is also nice, okay, but except that if you are a beginner, you may struggle a little bit, but with constant practice you get used to this method, and then you can use it anywhere. It is what? Accepted. However, it wasn't enough for me, so I was asking, wouldn't it be nice if I could get to know all the factors of a particular number? As in, how, if you ask me 12, how many factors can I get from 12? I don't know unless I find it. But is there a system for me to know, so that if, let's say for example, I omit 8 here and I count that, okay, I'm having 1 2 3 4 5 6 7 factors, 7 factors for 24, but I'm supposed to get 8. What system do I have in place to check that from so I make mistakes? There is a system, and that is what you are going to get into. So this method I'm going to teach you will help you to know the exact number of factors you are supposed to get. So if you are supposed to get 15 factors from 100, you should know, or 10 factors from 100, you should know, so that when you are falling short, you should know that and soon, have you gotten it? So that is what we are going to look at. But this is not as simple as we see it. It opens us up to a whole lot of problems. Alright? Because it relies on the principle of prime numbers. Alright? And what are prime numbers? Prime numbers are numbers that have only 2 factors. That is 1 and the number itself. Now, most times people confuse prime numbers with odd numbers, and I want you to get the distinction right from here. Alright, when we say prime numbers, I'm going to list some numbers on the board from 1 to 10. So 1 2 3 4 5 6 7 8 9 and 10. Now, I I will use this opportunity to explain the number systems we have, as in the type of numbers we have. So we have even numbers. Even numbers are numbers which are divided by 2 without any remainder. Any number you divide by 2 and there's no remainder, that number is even. Then what's an odd number? So let me give you an example of an even number. So examples of even numbers include 2. These 2 you are seeing here. So even numbers. Even numbers. Now from this set only, right? There are more, but from this set we have 2, 4, 6, 8, and 10. Alright, these are the set of even numbers. What about odd numbers? Okay, so the odd numbers are here. So odd numbers. So these are the numbers such that when they are divided by 2, there is a remainder of 1. Any number you divide by 2 and there is a remainder of 1, that number is odd. Alright, so let's use this to test our hypothesis. Now, if I have 1 divided by 2, this 1 divided, how many times will 2 divide this 1? 0, right? Remember what? 1. Okay, so 1 is an odd number. Now 2 divided by 2 is what? 1, remember 0, so it's not odd. 3, alright, 2 divides 3, how many times? 1. What's the remainder? 1. Therefore it is what? Odd. Right, 3. The next number, 4. 2 divides 4, how many times? 2 times, remainder 0. Therefore 4 is not an odd number because there's no remainder of 1. So 4 is not part. The next number, 5. 5 is odd. Why? Because 2 divides 5 2 times, remainder 1. Alright, so 5 is an odd number. Write 5 here. Okay, so you can see the pattern. 1, 3, 5, 7, good, 9, and so on and so forth. Alright, so from this set of numbers, the odd numbers are 1, 3, 5, 7, and 9. Have you seen it? Now let's move on to prime numbers. Alright, so prime numbers. Now we're going to know the difference between a prime number and an odd number from this. Now, what's a prime number? Like I said, a prime number is a number, any number at all that has only 2 factors. That's 1 in the number itself. What do I mean? Now, let's pick these numbers and let's test our hypothesis and see. 1. How many factors can we get from 1? It's just 1. Alright, so 1 is not a prime number. Why? Because it has only 1 factor, so it's not a prime number. What about 2? Let's pick 2. What are the factors of 2? The factors of 2 are 1 and 2. So 2 is what? A prime number. So 2. 3. What numbers can divide 3? That's 1 can divide 3. 3 can divide 3. How many factors do we have here? 2 is a prime number. Why? Because prime numbers are numbers that have only 2 factors. So 3 is a prime number. The next one, 4. What are the factors of 4? 1, 2, and 4. You see? How many factors do we have here? We have 1, 2, and 3. What's a prime number? Because prime number is there, you must have only 2. Only 2. If you get 3, 4, 5 there, it's not a prime number. Good. So our next number is what? 5. So let's see. 5 is equal to. Now factors of 5, we have 1 and 5. Therefore, this is what? A prime number. This is a prime number because it has only 2 factors. So write our 5 here. The next 6. Okay, let's test for 6 too. So 6. What are the factors of 6? We have 1, 2, can also divide 6, 3 can divide 6, and then 6 itself. Alright, therefore how many factors do we have? 1, 2, 3, 4, and you know, once it's more than 2, it's not part. So this is also what? Not a prime number. Have you got it? Good. Our next number we are looking at is 7. We have what? What are the factors of 7? 1 and 7. Therefore, it's a prime number because it has only 2 factors, 1 and 2. So this is a prime number. The next number on the list is 8. How many factors do we have in 8? 1 can divide 8, 2 can divide 8, 4 can divide 8, and 8 will divide itself. Alright, so this is not prime because it has more than 2 factors. So 8 is not prime. Let's see. Now this is where most of you get confused. You know, when I was a kid, I also used to mistaking 9 as a prime number, but today we'll prove that it's not. What are the factors of 9? We have 1. 1 can divide 9. 3 can divide 9 before 9 itself. Okay, so it has 3 factors, therefore it is not prime. Have you seen it? Good. So this is also not a prime number. So we only have, you know, 2, 3, 5. Oh, we didn't write for the 7, and then 7 in this set of numbers. All right, so this is how, if you continue this process, you find all the numbers all the prime numbers between, you know, 1 to 100 only. Okay, between 1 to 100 you can find all the prime numbers in between that. From here we are moving on to prime factorization, or you know, writing a number as a product of prime. All right, and so that's what we are going to do right now. Now with the prime factorization, we are going to use strictly prime numbers to do that, and so I'll be listing the prime numbers here. So we have, you know, the prime numbers. We have 2, we have 3, we have 5, we have 7, we have 11, we have 13, we have, you know, 17, etc., etc. Okay, these are prime numbers. So say I give you a number like 12 and ask you to write this 12 as a product of prime. How do we even do that? Easy. We have 2 methods you can use. Either you use the tree method or the table method. Okay, though the table method is my favorite, I'll teach the tree method to you too, so that the one that is easy for you, you decide which one to use. They are all accepted. Quickly, solution. So this is going to be 12 here, right? 12 here. I'm going to use the tree method. All right. So the tree method. Then I write my 12. Okay. So 12 like this. Now you have to look for factors that will divide 12, but one of the factors must be a prime number. All right. So we are going to shift our focus totally to the prime number we are going to use to divide the number we are given. All right, so what prime number can divide this 12? Did you say 2? Yeah, you are correct. So 2, we use 2 to divide. So 2 divides 12 how many times? 6 times, right? So we write our 6 here. Then we now focus on the other number. Okay, so this number, which is not a prime number. So now 6, our focus is now on 6. Now what prime number would divide this, you know, 6? 2, right? So 2 times what gives you the 6? Times 3. Okay, so 2 times 3 gives you 6. So I think This 3 is also a prime number. All right, so we just leave our answer like that. So 3 here. Okay, so rewriting this as a product means multiplication, so we write 12 is equal to what? We multiply all the prime numbers. Mind you, 3 is a prime number, I hope you know that. So 2 times 2 times what? 3. That's going to be 2 raised to the power what? 2 times 3. Why is it 2 raised to the power 2 times 3? Don't worry, anytime you see a number this is indices, and we'll treat this later as a standalone topic. So but then for a quick view into that, I'll just teach you something simple. So let's say I have 5 times 5 times 5. Now this is 5 multiplying itself how many times? 3 times, and you don't need to write all of this. In indices, you can just take 1 5, okay, and then represent as an exponent, represent the number of times the 5 is multiplying itself. So 5 multiplies itself how many times? 3 times. That's 1 2 3. So just write the 3 at the top, and that's what we just did here. So the 2 multiplied itself twice. Okay, so what if I have 6 times 6 times 6 times 6 times 6? How many times is the 6 multiplying in itself? 1 2 3 4 5. Just pick 1 6. So 6 raised to power what? 5. Have you seen it? So it's as simple as that. Nothing to fear. Now this same problem, we are going to use the table method to solve it. All right, so this is the tree method. I'm going to use the table method. Table method. Now with the table method, like the name suggests, you're going to use table. So write a 12, and then do these columns around it. Okay, so we start the same process, the same questions. What prime number divides this 12? So that's 2. So 2 divides, I use a different marker, red will do. Okay, 2 divides this 12 how many times? And that's going to be what? 6 times. So write your 6. Now you have 6. What prime number divides this 6? 2 again. So 2 divides this 6 how many times? 3 times. And then what number do we have here? 3. So what prime number divides this 3? And that's what? 3. So write your 3. 3 goes here, 1. And in this case, the 1 is an indication that what you finish dividing, so you've ended. So what you're going to be working with are these numbers, all right, over here in red that we see. So 12 is going to be equal to 2 times 2 times 3, which is going to be equal to what? 2 raised to the power 2 times 3. Have you seen it? Same answer. Okay, so whichever one you use is allowed. So let's pick another example. This time we are going to write 48 as a product of prime. 48 as a product of prime. So using the tree method for 48. So write 48 here nicely. So we go. What's prime number is 2 and what? 24. So 2 times 24 gives you 48. All right. So the next prime number we use is also going to be 2 again. Okay, you can use it as many as possible. So 2 times 12. All right. Then you focus on this, which is not a prime. Okay, after the prime there, by way here. So you don't bother it again. So this is going to give you 2 times what? 6. And this gives you what? 2 times 3. So you can see the prime numbers here. So 3 is part of it because prime at the end of it. You can see them here. Obviously, yes. So how do we write this as a product of prime? Easy. So 48 is going to be equal to how many? The 2's, they are multiplying themselves. 2 times 2 times 2 times 2. That's 2 raised to the power how many times? 4 times what? 3. So that is that. 48. Then we have this around it. So what prime number divides 48? 2, right? So you write your 2. So 2 goes into 48 how many times? That's going to be 24. Okay, then again you are here, focus on this. So 2 goes into 24. How many times? That's going to be what? 12. Still 2 can divide, which is a prime number. 2 divides this 12 how many times? 6. All right, now you are here. 6. 2 divides this 6 how many times? 3. So we have 3. So what prime number divides this 3? It's 3. Okay, it's already a prime number. So 3 divides this 3 and 1, and the 1 signifies what has been done with our work. So here we are. We have 48 is equal to 2 times 2 times 2 times 2. So that's 2 times 2 times 2 times 2 times what? 3. Okay, and that's going to be give you 2 raised to the power 1 2 3 4 times what? 3. You see it? Yeah, so that is that. Now one last example and then we will move on from here. So now let's do for 18. Okay, so write 18 as a product of prime. Okay, so using the tree method, we are going to have our 18 here like this, and then we are going to use our tree. So like we always do, our prime number is going to be 2. Okay, so 2 divides 18 how many times? That's 9. And then we focus on this 9. So what prime number divides this 9? Not 2. 2 can't divide this 9 because it's not even. So 3. So 3 times what gives you 9? So 3. Okay, so 3 times 3 gives you 9. Alright, so basically you can end your answer here. Okay, so you can focus on these numbers here. Therefore 18 is going to be equal to what? 2. No, 18 is going to be therefore 18 is going to be equal to 2 times 3 times 3, which is going to be equal to what? 2 times 3 raised to the power 2. Okay, so that is that. Now let's use a different number for the table method. Let's write 15 as a product of prime. That's just going to be what? 3 times 5. So I will need to go into that. So let's write 20 as a product of prime using the table method. So 20, I have my 20 here. Now prime numbers that we can use. First one we can use is what? 2. So 2 divides 20 how many times? 10 times. Then we have 10 now. What do we use to divide? 2. 2 as a prime number divides 10 how many times? 5 times. So what prime number divides 5? It's still what? 5, because 5 is here. It's still. So what prime number divides 5? It is 5, because 5 is a prime number. So 5 divides what? 5. How many times? 1, and that ends it. All right. So our product of prime 20 is going to be equal to 2 times 2 times what? 5, which is going to be equal to 2 raised to the power 2 times what? 5. So that is how to write any number at all as a product of prime. Now you will only get better at these things when you solve more examples. So now that I've taught you this, though I'll be sending you a series of questions for you to be trying, I will beg you that you also find the time to solve as many questions as possible just around this topic, and it's going to go a long way too. So now we have learned about prime factorization, how prime numbers can help us, So now that we've learned about prime numbers and prime factorization, how does this fit into our larger goal, which is to help us find factors of what? Numbers. Mind you, factors of numbers still mean numbers that can divide a particular number. So it's very simple. Let's take this example, 12. So let's use 12 as our first example. Now let's assume I just came to earth and I don't know anything about factors of numbers. How do I know that I'm supposed to expect about 5 factors or 8 factors or 9 factors of these 12? Easy. there's a trick you can use to help you find it, and that is what we're going to do today. It's very easy with 12 because you can just mention the factors, blah blah blah. But let's say something like 96 or 84 or 128 or 540. How many factors do you think you'll be expecting? Now, the prime factorization method we used is going to help us know the exact number of factors to expect. So quickly, this is what you do. I'm going to use the table method. So 12 here. So still under prime numbers. So 2 as a prime number divides 12 how many times? That's going to be 6. So what's our next prime number? 2 divides the 6 how many times? 3 times. 3. Now what's prime number divides 3? It's 3, but 3 is itself is a prime number, so 3 goes here, what? 1, and the 1 signifies that what we've ended our division. So we are going to work with these numbers. So we are going to have 12 is going to be equal to 2 times 2. Multiply only these numbers. 2 times 2 times what? 3. Alright, which is going to be what? 2 raised to the power 2 times what? 3 raised to the power 1. You should know that any number without a power means what? Power 1. Alright. Yes. So now that we have this is where I want you to pause and take your time and listen carefully. To get the number of factors you are supposed to expect, take the powers, add 1 to each of them and multiply them. So that's going to be, what power do we have here? 2. So 2 add 1 plus 1 gives you what? 3. This 3 here, what power does it have? 1. So 1 add 1 plus 1 equals how many? 2. So when you finish your answers, just multiply them. So 3 times, so this is going to be equal to what? 3 times 2 is going to be equal to what? 6. Therefore, you should expect 6 factors from 12 alone. Alright, and fortunately for us, the table itself here provides the factors for us. Can you see them? 1, 2, 3, 6, and 12. So we write this down roughly somewhere. So let's say you call this one the rough factors. So I write them down as, so 1, 2, 3, 6, 12. Now, how many factors have I written down? 1, 2, 3, 4, 5. But what we did told us that we are supposed to get 6 factors. So where is the last one? Easy, relax. So when you get here, after you are done, multiply any of the factors you see here, the prime numbers, multiply any of them, and you're going to get the answer. You don't believe it? Okay. 2 times 3 is 6. It's already here, so you don't need to write it. 1 times 3 is already here, 3, so you don't need to write it. But let's see, 2 times 2, 4. 4 is not in. 4 is not in here, so that means the last number left is what? 4. So just write it down, 4. So when you are done, you will now come and rearrange the numbers in ascending order or descending order. So factors of 12 are going to be 1, 2, 3, 4, 6, and what? 12. 1, 2, 3, 4, 5, 6, and this is correct. Yeah, I know you're excited, but relax. Let me give you another example so that you can actually be happy about that. Let's pick a different number we can find factors of. Let's pick 16. 16, okay? So 16. Find all the factors of 16. So then we go, our table method. 16. So write our 16. So 2 goes into 16 how many times? 8 times. 2 goes into 8 how many times? 4 times. 2 goes into 2. 2 goes into 4 2 times. 2 goes into 2 once. Alright. So like I said, these are the prime numbers I'm going to be using. Okay. So our 16 is going to be equal to 2 times 2 times 2 times 2. There are 4, right? 1 2 3 4, multiplying. Good. So the final thing is going to be 2 raised to the power 4. Like I said, when you get here, all you need to do is to deal with the powers. Now what's the power for this? Is just what? 4. So the 4 you are seeing, 4, just add 1 plus 1 is going to be equal to what? 5. Alright, this time there's no other number attached to it, like say times 3 raised to the power something that you need to multiply, but it's just this. So this is what you maintain. So we are expecting 5 factors. So now let's see if the 5 factors are here. I can see, so the raw factors, I can see 1, I write it down. I can see 2, I write it down. I can see 4, I write it down. I can see 8, I write it down. I can see 16 from here. So it's going to be, let me see whether they're up to 5. 1 2 3 4 5. Done. This is so easy to do. Yeah, I know you're enjoying it already. 24. Okay, 24. Yeah, let's go. 24. 24. Let's find all the factors of 24. So 24. Now, how many factors are we supposed to expect from 24? I don't know. Let's find out. So 24. So 2 goes into 24 how many times? 12 times. Mind you, I'm still repeating this. We are only going to use prime numbers to divide this. That is why it's called prime factorization. So 2 divides this 12 how many times? 6 times. 2 divides this 6 how many times? 3 times. And then 3 divides this 3 once. So we are going to deal with these numbers. So 24 is going to be equal to 2 raised to the power 1 2 3. 2 raised to the power 3 times what? 3. Okay. If it's just 3, then you raise it to the power 1. Okay. It's going to be equal to. So now that we are here, what do? We take the powers and then add 1 and then multiply. So 3 plus 1 equals 4. 1 plus 1 equals what? 2. And at the end of the day, you're going to just multiply 4 times 2, which gives us what? 8. Meaning we are expecting 8 factors from what? 24. So that means some of the factors are already here, but not all of them may be. Let's see. So the rough ones we have here, we have 1. I can see 1. I've written it. I can see 2. I've written it. I can see 3. I've written it. I can see 6. I've written it. I can see 12. I've written it. I can see 24. Right? Good. So 1 2 3 4 5 6. But I'm supposed to get what? 8 factors. Meaning I'm left with 2. Now here's the trick. Don't panic. You see these prime factors you are seeing over here. Multiply any of them. You can multiply any 2, any 3, any 5. The number you get which is not here, you write it down. Alright, so let's try. So 2 times 3, 6. It's already here. Don't write it. So 3 times 2, 6 times 2, 12. It's already here. So don't write it. Now let's see. 2 times 2, 4. Is 4 here? No. So 4 is one of the numbers. Now let's see. 2 times 2, 4 times 2, 8. Is 8 here? No. So write it 8. So you see 1 2 3 4 5 6 7 8. 8 factors. Therefore, we rewrite this in ascending order. So 24 is going to be equal to 1 2 3 4 6 8 12 and 24. So 1 2 3 4 5 6 7 8 factors. Have you seen it? As easy as ABC. Now I'm going to give you a question to try for me. Now let's try something a little difficult to see if you can get factors. All right, like I said, all of these things come with experience. The more you solve, the more you become conversant with them. So let's try and find all the factors of 96. Yes, 96. Let's go big. So I'm going to write my product of prime here. So 96. All right. So what I'm going to do here is I'm going to try and find the number of factors of 96 I'm supposed to expect. So my prime numbers, I can use 2. So 2 divides 96 how many times? That's going to be 48. Right. So 2 divides 48 how many times? 24. 2 divides 24 how many times? 12. 2 divides 12 how many times? 6. 2 divides 6 how many times? 3. And then we have 3 divides 3 once. Okay, so pause here. Good. So we are going to be working with this numbers here. All right, so 96 is equal to 2 times 2 times 2 times 2 times 2. So let me see, 1 2 3 4 5. So 2 raised to the power 5 times 3. Okay, so like I said, you will pick the powers. So you pick the powers. This is power 1, don't forget that. So you pick the powers. So it's going to be, and add 1 to each power and multiply them. So let's add. So 5 plus 1, what do we get? 6. Then 1 plus 1, what do we get? 2. All right. So when we multiply 6 by 2, we get 12. Meaning we are supposed to get 12 factors. This is crazy. Now let's see the rough ones that this has already listed for us. Let's list them here. Then we know what we are left with. So 1 is already here. So 1 2 3. Am I seeing 4? No. 3 6. I'm seeing 12. I'm seeing 24. I'm seeing 96. I'm seeing 48. Okay, so 1 2 3 4 5 6 7 8. So yeah, so I have 8, meaning I'm left with how many more? 4 more. How do I get those 4? Like I said, multiply any of these prime numbers here together. The number you get which is not here, then you add it together. Have you seen it? So 2 times 2, 4. It's not here, so we add it. So 4. Then we go again. 2 times 2, 4 times 2, 8. Is 8 here? Nope. So we write our 8. So 2 more to go. 2 times 2, 4 times 2, 8. 8 times 2, 16. 16, 16, 16. Nope. 16. Okay. Let's go. 2 times 2, 4 times 2, 8. 8 times 2, 16. 16 times 2, 32. Is it here? No. Yeah. 32. So let's see. 1 2 3 4 5 6 7 8 9 10 11 12. So I pause here and I write my answers. So 96, all the factors of 96 are in ascending order are 1 2 3 4 8 8 12 16 24 32 48 and 96. Let me see if they are up to 12. 1 2 3 4 5 6 7 8 9 10. 1 2 3 4 5 6 7 8 9 10 11. What is that right? 6. Then what? 6. Yeah. So this is interesting, and this will make your work very fast, and then you not get confused because you know when you are wrong because your factors are not up to. So with that being said, thank you very much for taking out time to listen to this all important video that I've made for you, and I think this simplifies things a bit. All right, so go ahead, take this method and then use it on so many numbers, and let's see how things go. Just explore. Yes, like I said, like I've always been saying, if you have questions concerning things like this or further explanation, don't hesitate. Ask the question in the comment section. I'll reply you. My WhatsApp, I'll reply you. You can reach me out on all the social media platforms, and my email will also be in the comment section, so you can reach me out on all of those media where I will answer all the questions you have. Thank you very much, and God bless you. Stay safe.